Okay, so we're on question number 3 here, and what we're going to look at now is the other way to use Hardy-Weinberg. So the first two questions, number 1 and 2, we're looking at Hardy-Weinberg when they give us the frequency of the allele. And of course, all we did is took that allele, found the frequency of the other allele, whether it was P or Q, popped that into the formula. But now we're going to look at the other way that they utilize Hardy-Weinberg. And the other way is where they give you the frequency of a genotype. And once they give you the genotype, this is generally how you're going to see most of the questions, is when they give you the frequency of the genotype. And when we're using the frequency of the genotype, what we must use always is the recessive trait. Q squared is what we have to be able to use. And we'll talk a little bit about that on why we need to do that in a bit here. So let's go through this question. It says, in a random mating population of mice, 25 out of 100 mice are born with white fur, a recessive trait. That's perfect. When we see trait, we know that we're talking about, and recessive, we're talking about Q squared. Recessive is being Q. When it's a trait, disorder, any of that kind of stuff, you have to have 2 of those alleles, 2 of those recessive alleles for it to be a trait. So we're talking about Q squared. So let's just put what we have here. Q squared equals. Now, we have to actually determine what the frequency is because they give us 25 individuals out of a total of 100 in the population. And when we do that, all we have to do is just divide that out very quickly, and we come up with a frequency of 0.25. Okay, and that is, again, Q squared. We know it's Q squared because we're dealing with a trait, and we know it's Q because it's recessive. Okay, so once we have that, we need to find a single Q. So when we want to find a single Q, what we have to do is square root the Q squared, the 0.25 figure, and we find out that Q now, when we square root it, because we want a single Q, is determined to be 0.5. Okay, and what they want here is they say calculate the frequency of each allele. So they're asking you for the allele Q and for the allele P. Okay, record your answer to 1 decimal place. So we have one of the values already. And again, the hardest part of these questions is when do we square root it? When they give you in the answer the Q squared value, in this case they told us it was 0.25, that's when we're going to square root it to find the single Q. Why do we have to do that? Because once we have the single Q, we can easily now go find P, because P equals 1 minus whatever Q is. So when we go 1 minus 0.5, that's going to give us P. We determine P to be 0.5 as well. Okay, and that's all we had to do for this question, because all they're asking for is the frequency of each allele, again, 1 decimal place. So there is our answer for this one. Any questions? Just give me a quick email. Thanks, guys.